you the update if that opens during the show, and if not, we'll definitely give you the update online. So here's a look at our satellite and radar, looking at those scattered showers. So you could be bumping into some wet roads today, but we will see decreasing showers as we go into the second half of your day. We'll also see those winds coming a bit. Now here's a look at the rain gauge so far today. Not that impressive compared to what we saw yesterday. We actually saw some pretty big numbers, and for that, Darren Peck, meteorologist Darren Peck, why don't you come on in here? We're going to talk about that because I want to talk about how much rain we saw yesterday.
Yes.
Why.
And why is the important part, and why we should all learn to recognize why this storm was unique. Take a look at yesterday's satellite imagery. Good looking storm here, but you can see the arrows going back down to the subtropics. I'm going to show you yesterday's storm in a somewhat different way now. Looks a little psychedelic, but this is the water vapor imagery in the atmosphere, and now you can see there's something really distinct. Here we are. Hawaii's down here. Look at that long line connecting us down to where Hawaii is in the subtropics. That is an atmospheric river. You've probably heard that term a lot over the last few years. These are the storms that are able to tap into all the moisture in the atmosphere here in the tropics and pull that up in a narrow ribbon and point it somewhere at the mid-latitudes, and if it happens to be pointed at us, we get a storm that has some very telltale characteristics we should all learn to start recognizing. First of all, there's been a lot of rain with this one. We got nearly 7 inches of rain out along the coast since this thing started about 36 hours ago. We picked up 1.5 inches for Bellingham. But in addition to a lot of rain, we get very little snow except for the highest elevations because these storms are so darn warm because they're coming up from the subtropics. It rained on Snoqualmie Pass for the majority of this storm yesterday, and even now it's barely a mix. It's kind of snowing, but there's a lot of rain mixed in with it. By tomorrow, we'll start to see some light snow. So let's talk about why this is important to recognize atmospheric rivers. If you take a look at how many we've gotten, and we're going to do this in a unique way. I've got October, November, December, January, and February on here. The number for each month tells you how many atmospheric river storms we received for the period of the last 30 years of the 20th century. And that's important because I'm now going to show you the comparison for how many we are likely going to receive in the last 30 years of this century that we're in now. Can you see the increase? This is research done by the University of Washington in the Atmospheric Sciences Department. And the numbers here shouldn't be read too literally or specifically, but the takeaway is here. In a warmer climate, the atmosphere will be primed to deliver us more, and in some cases far more, of these atmospheric river type storms towards the end of this century. These storms definitely have telltale characteristics to them.
When the game ends, you need football minds that can tell you what went down and what it all means.
After every game, highlights, thoughts, analysis. Don't miss the fifth quarter. Saturday night at 10, only on